test review, and then we'll look at your worksheets and see if you have any questions that pertain to it. So first off, the test. Started at 8:30 tomorrow morning. Close books, close notes, close computer. You will not have an application portion to the test. So therefore, you do not need your manual drawing tools. You don't need a visualization tool. This is going to be strictly an academic test. I'm going to allow 1 hour. Okay. So you'll get it from 8:30 to 9:30. The test is really going to consist of 20 to 25 multiple choice questions. And we're basically just going to test your academic knowledge of sections. I think if you look at this sheet where we summarized in essence the chapter, and this has everything except for our line standards on it that was introduced in that chapter. And I would expect a myriad of questions about these 14 terms. Okay. So in essence, you have actually 50. You have 8 rules that we use, and you have 7 sections. This will account for, the information on this will account for probably 80 to 85% of the test. We'll come back to that in a minute. The other 15% is going to be on your line standards. There will be a bonus question. So in essence, when I start for review, when I say the line standards, what am I talking about? I am talking about the 2 line types that we use in section views. Those would be cutting plane line, of which we have 2 that we use in sections. And we are talking about your section lines. So let's review those 2 first. When I say we have cutting plane lines, we have 2 cutting plane lines. Anybody tell me the 2 that I might use in sections? Yes, Lisa.
Break lines, short break lines, and that's your cutting line.
Yeah. Okay. So we have the actual cutting plane line, which we use on pretty much all the sections except for 1. Well, 2. I'm trying to find the page that is on. Clear at the end of the chapter, got to get to where to start. Page 767. Okay, so here's your standard cutting plane line. We use the one with the phantom characteristics, except that we change the phantom characteristics on line length. Okay. Remember, a phantom line is used to show movement, and it is a thin line. We change that for cutting planes, where we use it to show a theoretical or imaginary cut has been taken through the object. We change the line weight to a very thick line. That's really the difference. Okay. It will have arrows on it, typically, that denote line of sight. The arrows are always drawn 90 degrees to the cutting plane line. Keep in mind that the cutting plane line does not occur on the section view. It occurs on the view adjacent to the section view that shows where the cut occurs and your line of sight for the cut. Any questions on this cutting plane line? Yes.
Is there any standard on how long the line is for the arrow?
Not really. You're going to see that that's all over the place because once we start adding dimensions to it, you're going to have this cutting plane line. We want it off the object is what we want, outside.
Make sure it's 90 degrees.
But we want enough coverage so you can see the line. But then when we start putting dimensions on it, you're going to see it gets really crowded right offside the drawing. So sometimes we stretch it out on past the dimensions. Sometimes we leave it short. We actually obscure it at times. But just make sure it's clear. You know, you shouldn't have the arrowhead right here. It shouldn't just come in and have an
I was
arrow.
saying, sure didn't have to be the inch of the phantom, or it didn't have, yeah, it doesn't have to.
Yeah.
Okay.
But no, there's no set standard that I know of on that length. If you don't have anything in your way like you don't now, make them the same on both sides. Because we haven't introduced the dimensioning portion yet. All right, any other questions on this cutting plane line? The other cutting plane line we use in sections is shown. I'm not going to go back to the alphabet lines, we'll just use an example out of the text. Let's go to the broken out section on page 776. Okay, it's our standard cutting plane line we use for all of them except for really two. One of them is the broken out section where we use the short break line. Again, we've covered this pretty extensively, but very thick line. The form of it is symbolic of the material being broken. Keep in mind you use this for two sections. You've got the broken out section that we use it for, and then if you turn the page to page 778, when we do a revolved section, we also use this short break line, as shown right here. Does a revolved section get a cutting plane line also? Yes, it does. Okay, so you're using both cutting plane lines. And remember with the revolve, we still show the standard phantom line cutting plane in the adjacent view. The other line type we are talking about with sections occurs in the section view itself. And I'll go back to page 769. We call this a section line. What does a section line represent? Okay, it may or may not denote material. Yes, if we know the actual material, then we use the pattern that is associated with that material. Keep in mind, we don't always know the material. So therefore, if we don't know what the material is, we can use a pattern, and it's symbolic in nature just to represent that there is a cut or a surface created by the cut. Okay. So that one's kind of that gray area that we mentioned. A section line may or may not denote material. Typically, when we do a section line, we use this pattern if we don't know the material. It is a thin line, 1/8 inch apart, typically rotated approximately 45 degrees. Consistent line weight, thin. Any other questions on section lines? Hey, if you know all the properties of those and why we're using them, then let's look at the 7 sections. Are there any questions on a full section? Full section, cutting plane line passes completely through the object. The resulting section view will be drawn using orthographic projection at the location of the cut.
That was too quick.
That's too quick. I forgot what I said.
I think Andy's videotaping.
That's right, that's the whole point.
It's okay, proceed.
Yeah, full section, let's see. Works really good on linear objects. Our most widely used section is a full section. Keep in mind, there is a caveat on the cutting plane line that states that you do not have to show the cutting plane line if the location of the cut is obvious. And that's in your text as well, as I think I've mentioned it a couple times. This is the section that generally we wouldn't show a cutting plane line with because the sections are obvious and they don't change. Again, I would reiterate that for your drawings in here, we will not invoke that convention. We want to draw those cutting plane lines till we get quite used to them. For the purposes of the test, you can stick to that part though, because I'm going to ask this question. Or it will be something. You do not have to show the cutting plane line if the cutting location of the cut is obvious. Kind of like when you abbreviate words though. If there can be any doubt, what should you do?
Write it out.
Put it in. Yeah. Just like when we use abbreviations, the old term, if there's going to be any doubt, spell it out. Don't abbreviate. Any questions on the full section? Half section? Know about this one. Okay, this is kind of a different section. In fact, let's pull it up on the screen. Shown on page 775. When we do a half section, we have one arrow. Notice the cutting plane kind of is changed here. It comes through here, no arrow on this side. We're looking this way. We're going to throw a quarter of the object away, this quarter. We will section view from the center out. We will give the outline view in the other side. No hidden lines. As is shown in number C below. Any questions on this section? Works really good on circular objects. After that, we came to the broken out section. The one section that does not get our cutting plane line. This is like we reach in, rip a piece off, use a short break line. The section view occurs on the view we just define as our section also. The rest of the object that is not broke out goes through standard orthographic projection. So you do have hidden lines with this one. Okay, so this whole thing would be standard orthographic projection. We break this part out, section view it. Any questions on this one?
The hidden lines are only in the non-broken out part.
That is correct.
Okay.
Once we get into the section part right here, we're following the 8 rules above. Yes, Amy?
What was it that you said? The hidden lines are only in the where it's not broken?
Yes.
That is correct. Over here in the unsectioned area. After that, we come to 2 sections that are very similar. We've got the revolved and the removed. So the revolved is shown on page 778. We do have a cutting plane line denoting strength. Remember, I made the analogy of a slide that we look through a microscope. We're going to take a really thin slice right on that line. We are going to rotate it from this view to this view, and then do another 90-degree rotation like such. Okay. So we take that thin slice here, and then rotate another 90. We're rotating about this line. It does get the cutting plane line. The preferred way is to include some short break lines like here, so that we get a little definition and it stands out a little bit. Great section for these structural pieces that we never really get a look at. Okay. These ribs, webs, handles, arms, whatever you want to call them, that join pieces together. This is a great section for that.
So we disregard the rule about not doing the revs and.
No, no, you don't disregard them, but keep in mind, why is this all sectioned? Where's the long axis of all these? It's this way, right? Okay, we're cutting perpendicular to the long axis, therefore they're going to be sectioned. Okay.
And the true size.
What's that?
And true size.
Oh yeah, it's orthographic projection. It'll be true size on that cut. Any questions on this one? Now, if we don't have enough room right here, then we go to the removed, which is shown on the next page. Now, we have to do something different if we're going to remove it. And that is that we must identify where that removed view is, so we're going to add some things to our cutting plane line, in this case A, and you're going to see down somewhere else a title that says section from A to A. There's two A's here because we're going to go from A to A. So we need to add that so somebody can find the view. In essence, it's the exact same process as the revolved view. We just don't have enough room to put it here, so we're going to pull it out. Cutting plane line works the same way except for the A's, or B's, or C's. Again, another really good section for structural pieces that we can't get in to see. We aren't really there at this point, but we have mentioned it before. You also can use this like the convention in chapter 9, where we did the removed convention. We can pull this out, change the scale to show small areas. Keep in mind when we call these can be a removed view, they can be a removed section, they can be a detail. They got a lot of names. A cut, things like
I really have been wondering, what's the difference between the removed section and the removed convention?
change of scale. That's really the difference.
So with the removed convention, you alter the scale?
Yes. Yeah. So this would be a case of a removed convention and a removed section. Okay, now keep in mind, when we pull this out, are they rotating this 90 degrees?
Yeah. No?
No. They're just saying, this thing's shown, I can show the whole object quite well here, except for this little joint right here. And so we're going to pull that out. They're not rotating this. So again, there's a nomenclature. We've got the little circle. We pull it out. This is really the removed convention, and then we section it. So we still call it a removed section. I'm not going to go there on this test. We will be living with this view next semester. Okay? This is really a large part of what we as drafters do, is these removed views. If we all think of, buildings, bridges, whatever we draw, most things are quite big. And so we've got to get down and be able to show how we join stuff together, and that's primarily what these views are used for. Are we going to bolt it? We're going to weld it? We're going to just set them next to each other? What are we doing? Keep in mind, when we change that scale, we can get down and see screws, nails, bolts, these types of things at those scales. Okay, any questions? I'm going to focus really primarily just on this portion of it for now, because that's what we're discussing. Any questions on those two sections, the remove and the revolve? Then we have the offset section. Just showing, I'll just keep the middle part in here because that's the correct one. The offset section, again, our cutting plane line changes here. This is an offset section. It's very similar to a full section, except that we bend the cutting plane line to pass through critical areas of the object. The bend in the cutting plane line is always 90 degrees. And we do not project those bends. And then we section it as normal.
What does it do again? The opposite? Like, what is it for?
It's used to pass through critical parts that are not on the same Y or X axis, I guess might be a good way to say it. Because if they were all on, in this case, the same Y convention, you would use the full section, right? But in this case, we're changing Y critical from here to here to here, so therefore the offset section works nicely. Keep in mind, one other thing we didn't discuss on this is you can't come up and then backtrack. We can't show both of those here, right? So it starts on one side and goes to the other side. Any questions on the offset section? Okay. If we do need to backtrack, we do something like this example on page 781. We actually do separate section views. All right, one more section. Then the align section. And where's this character shown? Toward the end. It starts popping up on page 787. I'll go to 788. That's probably the best example. So the align section uses the revolve convention and then sections it. Keep in mind your cutting plane line bends to pass through the critical area. Then we rotate that to the quadrant point. That's the revolve convention. And then we section the resulting view. Works great on items, again, around a center. Now, would you use a half section? Yeah, I would if I had one of these spokes that came down to the quadrant point. I'd probably just stick with the half section. But if I've got to take that and swing it, then I need to go to the align. Any questions on the align section?
Well, if you're swinging it down and you're illustrating it, but you're not really saying that you're rotating it, why does it matter to do the top and the bottom?
Because we've got to take our cutting plane line and show them over here what we're going to section. And so we're changing that. So I can't really do a full section, can't do a half section, but I get a misleading projection down here. So in essence, we had the powers that be that developed all these way back in whenever. I don't know, I didn't know any of those people. They say, hey, we need another one, I agree with them. And we get a lot of these items.
Now, when showing that, would you just show that one in section view, or would you put the in?
This would be my front view.
Uh-huh.
This would be my right side view,
Okay.
right there. All right, there is your 7 sections. Keep in mind your author in the text states there's 8 of them. For the purposes of your test, I will not call out for 8. Just those 7.
Yes,
Okay. After that, there will be some rules that I talk about. Any of these rules that you would like to go over?
Number 7.
Number 7? Okay. 7's really got 2 parts in it. The first section, all the way till the last line, so from the start to right here, has to do with structural items and trying to not give a false impression of mass. After that, we do have one statement at the end that just says standard parts are not section line. Remember, a standard part is any part we buy from a vendor. Okay, so do I need to cover that part, Andy?
No, I got that.
Okay, let's go to this part then, and that is our structural items. These are shown primarily starting on 784, 785 are the examples. So when we have these items and we're cutting them, like here they call it a rib, web, flanges, lugs. We've also got spokes, arms, all these different items. Okay, the general rule on this is when you cut parallel to the long axis of them, they don't have mass. Okay, they're thin, they're considered thin parts, like in section B here. We're going parallel to the long axis of that structural part. So that's not going to be section line. We're still going to draw it in fold. We're still going to project it and draw it in fold. We just don't section line it. Now, if I cut perpendicular to the long axis, then I do section line it, as in section A. Now, the thing you really got to watch out for here, I think that's kind of fairly straightforward. When we cut right down the middle of those things, we're not going to section line it. The thing you really got to watch out for, in my opinion, is the ones that are continuous, thin structural items, continuous about a center. Because then we do section line those. It's almost like you're going perpendicular, as you see down in this example right below it. Okay. So to compare and contrast, okay, we're going to come through, okay, we're cutting it parallel to the long axis. This does not get section line. This isn't any thicker, but it has mass in a circle. And if I had one like this one that was constant, you can kind of see this one doesn't have the spokes that these others have. That would be this area. It's continuous about a circle, even though it's a thin structural item. So we still section line those. But that's what you want to look for. Is it an item that's thin and there, or is it go all the way around, like on that one?
Going back to page 785,